Do you want to build a triangle? It's got 3 angles and 3 sides. Sometimes it's really obvious, but other times it's ambiguous. If I give you information, will you know exactly what the triangle looks like? How many sides and angles do you need to make it unique? Okay, bye. I hope your ears are not bleeding too badly, but, well, maybe you get the point of what we're doing here. So we're going to make a triangle. Goodbye, Olaf. I hope I don't get sued for, copyright infringement. So if I give you information and I ask you to draw a triangle, then how on earth, oh geez, okay, let's get rid of that. Okay, how on earth are you going to draw it given the amount of information I actually give you? So I'm going to do a little something here, and let's see if you can play along. I'm going to give you enough information to draw a triangle, and I would like you to try and draw it. All of my triangles are going to be referencing, basic, let's see, like a basic sort of triangle that maybe looks like this. We've got an A, we've got a B, and we've got a C here. And here's a little C, and here's a little A, and here's a little B. If I give you a certain amount of information, can you draw the triangle? So let's just do a little fun one here. I'm going to give you all 3 sides of a triangle. So I'm going to tell you A equals 10, B equals 8, and C equals, I'm just going to say 6, okay? Take a second, just sketch it out, or even imagine it. The triangle you draw and the triangle I'm about to draw, are we going to draw the same thing? Okay, so if we do this, so it doesn't have to be oriented exactly like my sketch, but I might as well. This will be something like, we'd have a side of about 10, and then B would be a side of maybe like 8, but I don't know which way it's going. Okay, so B could be down here, but then side C would be over here, and it would only be 6, and it's not going to connect up. So I need to definitely make sure I draw this in a certain way that the sides all connect up. So what I can see is it's probably going to be something maybe like that. We'd have a 10, an 8, and a 6. Now, is there any other way you could have possibly drawn this triangle, aside from taking the whole thing and kind of rotating it around? The answer should be no. There is one way you will draw this triangle. If I do something a little different and I give you all the angles, A, B, and C, and maybe I give them, let's see, something like, I don't know, let's make it 80, 60, and 40. Will we draw the same triangle now? And if you go ahead and you try, okay, well, we've got angle A. So angle A is down here, and it's going to be about 80 degrees. And then angle C is down here, it's going to be about 40 degrees. And I know the lines have to connect up, right? So they're going to go maybe like this, and 40 is a little smaller. And then maybe up here, we'll have B, which will be like 60 degrees. So that'd be 60, and then we would connect it all up. Did we draw the exact same triangle? And the answer to that is, well, same shape, but you could have made a smaller version of it, right? You could have scaled it down. So we're not always going to draw the exact same size triangle, but we'll definitely have the same shape. Okay, what if I went with something here, and maybe I'll just erase all this business, and what if I went with something that I gave you, I don't know, a combination of a couple sides and angles. So maybe I told you angle A and angle B, and I gave you side C. So this is a little c. Let me draw it really little so it looks very little. Little c. Okay, so then I gave you, like, let's say 80 degrees, and I gave you 60 degrees, and I gave you like a length of 10. I'll put the degree symbols there to make it really clear. Would we draw the same triangle? So if I did this, and again in my sketch I sort of had it something like this, right? Here's A, and here's B, and here's C, or something like that. Okay, so A would be fixed at 80 degrees. There's no debating that. And B would be somewhere up here at like 60 degrees, although that's definitely not 60. And then side C, I told you exactly the length of side C, which is this side here. And that would have a length of 10. Then if I had to connect the rest of the triangle, well, this side could kind of extend off forever, and so could this side. But if I gave you this length here and these two angles, is there any other ways we could have drawn this triangle? And the answer is no. My apologies. It is allergies time for me. All right, so that's one unique way we can draw this triangle if I give you this information. But now I'm going to do something a little different. I'm not going to give you side B. I'm going to give you, sorry, I'm not going to give you side C. I'm going to give you side B, or maybe A. One of the sides that's not connecting it. So let's give you B. Let's make B a length of 10. So we'd start by writing this. We'd have like 80 degrees here. We'd have 60 degrees here. We don't know how long this side connecting them is. And we even, let's see, side B, I guess, would be the one down here. So we know this side here is like a very fixed length. Would we be able to draw the triangle uniquely? And I need this dotted side here. I need this to actually connect up. But I know this side here is like 10, so I have a gap. So what I could do is I could shrink this up. I could actually take this and I could, I know it's got to come down at a 60-degree angle, and if I did this here, and I could have it go down like that, I think I'd actually wind up making a triangle that was fairly unique. But is there any other way I could actually draw a triangle like that? So you might give that a little bit of thought here. So it turns out that this is really the only way I can draw this triangle. If I give you two angles on one side, we're pretty well fixed, and we're all going to settle on the same triangle. Now I'm going to give you the last hypothetical. I'm not going to give you two angles and one side. I'm going to give you one angle and two sides. So let's say this is 80 degrees again. I'm going to give you side lowercase b and lowercase c, and I'm going to give you something like, oh, I don't know, how about, let's see here. I'll tell you this one will be like 10 and this will be 8 or something like that. And then we'd have A opening up as 80, and then we'd have side B, which would be one of my adjacent sides. So side B would be 10. Side C in my diagram up here would be the one adjacent here, and that would be 8. And I haven't told you anything about the other side, so it could be any length. I haven't told you anything about the other angles, so they could be any degree, and we're going to have there's only one way to connect this, right? Okay. So now I'm going to do one more thing here, and I'm going to give you the case where you've got erase. The case where you've got A is equal to 80. Side A, which is opposite, is equal to some fixed length. Let's make that like 10 or something. And then side B or C, I don't know if I really care, but I'll just give you one of the adjacent sides. And I'm going to make that, let's see, so that's maybe like, oh, let's make it 15. Okay, so what we've got here is we've got a situation where A is fixed, so that's 80 degrees. One of my sides, so B, this one is fixed at about 15, so that's going to be about yay long. And now, this side here, which is C, we don't know how long that is, right? That's side C, we weren't given the length. Here's B, here's angle A. And what if I now had to try and connect this up? I don't know what angle this comes off at, so it could come off at any angle, really. I don't know what angle this top connector is going to come off at, so that could go at any angle from there. I don't even know how long the side is. The only thing I know is how long side A is, and side A is 10. So here's the thing, if side B is 15 and side A is 10, and I try and connect this back up, maybe I try and draw a line back up there, is this even going to connect up? Is this long enough if this is a length of 10? If you're looking at this, you might go, no, it's not long enough. We need to have it longer. So maybe I make this a length of 15 as well. So if this was 15, I could connect this up. But if I went like this, chances are it would be too long. It would actually go too far. Now I could make this a triangle by maybe making this go out like this, and then it would connect up, and life would be good. I'd actually have a nice little isosceles triangle there. And that would definitely be a possibility. But where things get really interesting is what if I make this like a length of, let's say, 13, and I'm just kind of making up a number here. If it's 13, it should probably be able to go and connect up like that. There's a fairly good chance. But what I need to start thinking about is I need to start thinking about what's the absolute shortest distance from here to here. So what's the length of that? Because it definitely has to be longer than that shortest distance to connect up. I could also, if this was 13, then there's a decent chance that maybe I could have connected it up like this, and I could have made a different triangle. So we start to get into the situation where if you're given information in a certain way, and in this way it seems like one angle and two sides, angle, side. Oh, I just about caught myself. Well, okay, yeah, you know what I was about to write. Anyway, that's why sometimes we go side, angle. Anyway, I get into the situation where I actually can draw a triangle more than one way. And it's not necessarily obvious, but there's some certain conditions out there, and that's what we're going to look at. So this is what makes the ambiguous case. If I give you some details about a triangle, sometimes it's ambiguous what the triangle looks like, and ambiguous means we're just not really sure. So this is what this lesson is going to be about, this part 2. Here I just want to do a little drawing for you. This is something a little more organized. This is what happens when I give you angle A equals, and you can see on my protractor here I've got 30 degrees. Now, what I gave you here, if we imagine C is going to be like somewhere along this line, so this will be like side A, and then this will be side C, and this will be side B. If I gave you side C, which it looks like I've actually given you the length of that, and I don't know what that is. If I had a ruler, I could probably measure it out. I'm just going to say it's about 10 centimeters, so it looks about right. And I haven't really given you any other information, so all I've told you there is, let's just say this is about 10 centimeters. I can form a triangle if I go along here and I go like that, or if I go along here and I go like that, or I go along here and I go like that, right? So I can form a whole bunch of different triangles. But if I fix this information here, what I need to do, of course, is I do need to give you one more piece of information. I cannot ask you to draw a triangle with only 2 pieces of info. I need to give you 3. So let's give you one more. Let's give you side A here. Okay, so now we have an issue. Because as I was mentioning before, side A is going to be out here. It's going to kind of be flopping around. If you almost imagine like a rotating arm, like it can rotate around anywhere it wants, it's maybe some fixed length that I'm going to define, but I have not told you the angle. So if I give you the length, what we need is we need a way to think about how long does it have to be so that it connects up here, and if it's longer than that, what are my possibilities? So the shortest length from this kind of hypotenuse down to here is if I draw a perpendicular little arm coming off like that. So we have an interesting situation where the shortest distance right here, that is the shortest possible distance to connect this up, and that is what side A would have to be. So side A has to be that long to make a triangle. If it's any longer, there's a chance that I can actually wind up making a couple different possible triangles. Like if it's longer, I can make a triangle that goes up and connects like that, but it could also go and connect like that. If it's shorter, it just won't connect at all. So what my whole goal here is to figure out what is an expression given the information I have to figure out what that shortest distance would have to be. So this is a really easy thing. If I'm actually given angle A and side C, what I can do is I can think about a right angle here, and I can form an equation that says sine of angle A is equal to opposite over hypotenuse. So this shortest distance, I'm just going to call this x. So this would be opposite, and in this case, the hypotenuse is the side opposite from my right angle here, which is equal to 10. Now, in general, I might even just leave this as side C. So what I have here is I have that this side would be 10 sine A for the sake of just simplicity or generalization, I guess here, I can include that as C because C is going to vary. It's something you're going to be given, but it's going to vary here. So x, which is the shortest distance that this side here can be, would be given by C sine A. So what I can say here is if I want to make a triangle, this side A over here, this must be at least C sine A. Okay, if it's not that long, I can't even connect it all up. If it's some little short thing, I can't connect it all up. So it needs to be at least that long. Now it turns out that if you're wondering, okay, that's the least it can be, what's the most it can be, or is there a most? There is actually a most. If you think about it this way here, I'm going to insert a circle. Okay, so here's a circle. I'm going to put it down there, and I'm going to go like this. The reason I'm talking about a circle now, if you think we're talking about triangles, we're actually talking about circles. It turns out that both of them are definitely, let's go to no fill here, both of them are definitely related because what a circle is it's a way of marking out all the different places where if I had a length of, let's say 12, well, where could that arm end up at? All these different places on the circle. So if I have a side A that's equal to something bigger than C sine A, then I could have it connect up like this, and I could have it connect up like this, and exactly where the circle intersects that dotted line, those would be my two triangles. So one of my triangles could have looked like this, and the other triangle could have looked like this. So my question was, though, is it possible to have too large of a side? And absolutely. If you actually take this circle here, let's stop making, let's take this and let's expand it. If we made this circle really big, like we made that other side way longer, we'd wind up getting our circle so big, like this, that when I actually go to try and connect up my side A from point B here, I'd wind up being all the way out here. So I could connect it up like this, but this side here, I can't go back because it's actually too long. It crosses past this point. And we'd actually wind up having only one possibility for a triangle, and my triangle would wind up looking like this. Okay, so what's kind of the whole take-home message of this entire thing here? Well, the big take-home message is this. If you want to know if the information you're given can give you one triangle or two triangles or zero triangles, it's this. So the requirement is that side A has to be at least C sine A. So side A better be bigger. Let's actually write it this way. Side A better be bigger than C sine A. But it also cannot be too big. So if we actually look at side C here, so in this case I said, let's say for example, it was 10 centimeters, but just in general, it cannot be longer than side C. So it's got to be bigger than the shortest distance, which is C sine A, and it's got to be less than the length of this fixed, we'll call it the fixed leg of the triangle, I guess, although I guess it's the hypotenuse. So we have this condition here. If you have this situation, if side A is larger than C sine A, which is the shortest distance x, but it's shorter than the hypotenuse, which is C, then this results in the possibility for having two triangles. I don't know why Word is doing it weirdly like that, but there you go. So this is the condition for two triangles. Now, if you're looking at this going, cool, that's not exactly what's in the textbook. Well, it's because the textbook just goes one step further, and I'm going to do that as well. Everything gets divided by C just for the sake of cleaning it all up, okay? So what your formula actually winds up looking like is this. So I'm just going to erase, I won't erase this, but I'll just write it up top like the nice, neat way. The two triangles are possible if sine A is less than A over C is less than, that actually turns out to be, and this is what you'll find in the textbook here if you're looking, and this is the check, okay? So basically it's this. what we need for this formula here is we don't need to have A's and C's. We need this letter to match this letter up there. That is super important. So if we're ever given a triangle where we have one side, two sides, so SS, that we're given one angle, so A, and we can use this equation here to determine whether there's two possible triangles. This is how we can wind up with what's called an ambiguous case. Okay, so anyway, if that all made perfect sense, I'm super happy. If you're still a little iffy on that, that's okay. I know this took me a while to really fully appreciate, and we'll wind up using this formula a whole bunch as we wind up going through and doing the next examples in the homework and on the notes. So for now, I'm going to stop right there. I think I need to take my allergy medication right now, and I'll be back with some more great, wonderful, ambiguous case. See you in a bit.